Okay, so this is the 12A sample space review for the retake. Let me grab a pen. Okay. Okay, so it says we roll a dice and spin the spinner with 3 equal parts. The spinner has the parts A, B, and C. So I could roll a 1 and get an A. I could roll a 1 and get a B. I could roll a 1 and get a C. Okay, then I could do 2 with an A, 2 with a B, 2 with a C, and you continue on. So 3A, 3B, 3C, 4A, 4B, 4C, 5A, 5B, 5C, and 6A, 6B, and 6C. Oops, 6C. Okay, and if you want to count these up, you'll notice that there are 1, 2, 3, 4, 5, 6 columns and 3 rows. So there's 18 different ways that I could do this. Okay, but this question is, what is the total number of outcomes? Well, we counted and we said 18, but how do we know that there's not more? How do I know that there's not something else that I haven't thought of? So the reason is the fundamental counting principle. And so the fundamental counting principle says that you multiply the number of choices for each event. So for a dice, for rolling a dice, there's 6 possible outcomes, right? You can't get anything other than a 1 through 6 if you're rolling a standard die. In this problem, we're talking about a standard die. And then this spinner, this particular spinner, has 3 outcomes, A, B, or C. So when I multiply these together, I get 18. So I know that's a total number of ways I could get it is 18 ways. Okay? Number 2. A bag contains the letters that spell out the name of the city, Chattanooga. Find the theoretical probability of drawing one tile at random for each of the following. So first of all, we need to know how many letters are in Chattanooga. So let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm just going to double check, but I think there's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, there are 11 letters in the word Chattanooga. So we're finding the theoretical probability of drawing one tile at random for each of the following. So for A, so remember probability is the number of successes. So the number of successes divided by the total number of outcomes. So in the word Chattanooga, there are 3 A's. So there are 3 successes, 3 A's, out of 11 possible outcomes. I could draw 11 letters. Okay, so my probability is 3 out of 11. And you have to be careful that you reduce when possible. In this particular case, you can't reduce. But if your answer was like 6/8, that could be reduced into 3/4, and you would need to reduce, okay? So just keep that in mind. Okay, so the probability of an I. So again, remember probability is the number of successes divided by the total number of outcomes. So how many outcomes are there? How many letters are there? 11. And how many of them are an I? Well, 0 of them are an I. So I get 0 divided by 11. And 0 divided by 11 is actually 0. You have to write that down. You can't just say 0 out of 11. You need to divide that out. So 0 divided by 11 is 0. Okay, and for this last one, it says a probability of not O. I think that looks like a 0. That's funny. I think I did type in a 0 there, but I meant it to be not O. Okay, so what's the probability of me drawing a letter that is not an O? So there's a couple different ways. I can count all the letters that aren't an O up. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters that are not an O. An easier way to do it is there are 11 letters total. There are 2 O's, so that means 9 letters are not O. So my answer is going to be the number of successives, which is 9 letters that are not an O, out of 11 possible choices. Okay? Now we're still using the Chattanooga example, and we're saying that, and after an experiment, the table shows the results of 77 trials. We want to find the theoretical and experimental probabilities. Okay, so we're doing this for all the letters. Remember, Chattanooga had 11 letters. So the theoretical probability of rolling a C is 1 out of 11, or of choosing a C is 1 out of 11. For an H, there's 1 H, so it's also 1 out of 11. For an A, there's 3 A's, so it's 3 out of 11. For a T, there's 2 T's, so that would be 2 out of 11. And for N's, it looks like there's only 1 N, so that's 1 out of 11. O, there's 2 O's, so that's 2 out of 11. And G is 1 out of 11. Okay, now to find the experimental probability, we look at this. So they did this experiment 77 times, and they drew a C 8 times, so the experimental probability is 8 out of 77. And we need to see if that can be reduced, and it can't, so I'm going to leave that be. Okay, they rolled an H 11 out of 77 times, which is 1/7. That can be reduced. Okay, they rolled an A 21, or not rolled, chose an A 21 out of 77 times, and top and bottom can be divided by 3 there, so that looks like 7/11. I'm sorry, top and bottom can be divided by 7, and I get 3/11. Alright, they drew a T 15 times, so that would be 15 out of 77, and that cannot be reduced. N, they did 7 out of 77 times, and that can be reduced to 1/11. They drew an O 6 out of 77 times, that cannot be reduced, and they drew a G 9 out of 77 times. Okay, so the question is, for which letter or letters is the experimental probability the same as the theoretical probability? So let's see when these are equal. This is 1/11 and that's 8/77. 1/11 and 1/7 not equal, but look right here. A, 3/11 and 3/11. So A is one choice. Let's see if there's any more. We have 2/11 and 15/77, 1/11 and 7/77. Oh, which is 1/11. Look at that. Okay, and then 2/11 and 6/77 no, and 1/11 and 9/77 no. Okay, so the letters are A and N is when the theoretical is the same as the experimental. Now we have to explain. Okay, so for A, the experimental probability is 3 out of 11, because there are 3 A's and 11 letters. Because there are 3 A's and 11 letters. I'm sorry, and this should have been for the theoretical probability. For the experimental, there were 21 A's, out of 11, or out of 77 trials, which reduces to 3/11. Okay, and I'm running out of room here, but I can make a similar argument for why n works. So n works the same way. We're just going to say. Okay? All right, so in order for you to complete the retake, you have to do the following problems. Try the following problems on your own. You have to bring them either to your teacher, a support teacher, or a math lab person. And then once you have these answered, you can take the retake. Okay? So good luck. So here's problem number 1. You're rolling a die, flipping a coin, and spinning a spinner. Problem number 2, a bag contains the letter tiles that spell the name of the city, accommodations. Okay. And then finally, you have to fill out the table with the theoretical and experimental probability. All right. Good luck.